Hello, in this video I will talk about how important it is for every engineer to be extremely careful with engineering problems. And even if you are the best of the best on this planet in engineering, you can also make a mistake. For example, engineers at NASA in 1999 made a mistake of not converting units. A very simple mistake, but it resulted in a loss of $125 million satellite. And as for students, such simple mistakes can result in loss of grade or points. So that's why in this video I will consider two different questions, two completely different questions that look nearly identical. And this is to show how important every single word of the problem is. And in this case, there's actually just one difference, which results in two completely different results. So the first question asks, when two fair six-sided dice are thrown, what is the probability that exactly one even number will appear on top? And when it comes to problems with dices, I really love using this graph. It makes it very easy to calculate anything with two dices. And in this case, I'm just interested in cases where just one number on top is even. So I will just put stars where the outcome is just what I'm interested in. Not a very nice star, but whatever. And you might have noticed a pattern here, and yes, this table has many patterns, and that's another reason why I like it, because it makes very easy to do calculations with dices. So in this case, any star here is an outcome where exactly one dice is even. For example, 4 and a 5, that is only 4 is even, so we have a star here, and that basically works for anything here, and this means 18 out of 36 or 2.5 probability. So if you count stars here, you will have 18, so that's why. And now let's look at another problem, one on the right, which is absolutely different from the one left, and certainly has completely different answer. So let's read. When two fair six-sided dice are thrown, what is the probability that at least one even number will appear on top? So the difference between these two is that one on the left asks for exactly one even number, while the one on the right asks for at least one even number. And that means anything that has more than one or exactly one falls under this condition. So with this graph, we just need to add the cases where we have two even numbers. So that means anything where we have at least one. So if we have two here, I will just put stars on it's on its horizontal, because no matter what's the second thing, we have at least one even number. So let me just fill the stars according to that pattern. And another thing is that we have even numbers on top also, but when you fill ones for horizontal, the verticals are filled by themselves, which is awesome. This graph is miracle. It's very awesome. So if we count them, we have 3 times 3 and 3 times 6, and their sum is 27. So 27 over 36, 27, that is 0.075, that equals 0.075. So as you can see, the answers are completely different. even though the problems look nearly the same. They look nearly the same, but the answers are absolutely different. And that's because we changed just one word here. So this just again proves how careful we have to be with engineering problems. So to recap, we looked at failure of NASA with conversion of units just to raise awareness of how important it is to be very careful in engineering problems, and we considered another case where just one single word can result in two different outcomes, two different answers, and that's why we have to be extremely careful with every single word, because if we fail to correctly interpret the question, we will get the wrong answer. So be careful, and thanks for watching.